Good morning, everyone. Welcome back. If you've been joining the last days, glad to have you back again. And for people who are tuning in for the first time, you're more than welcome. And there will be more lessons, of course, in the coming days and next week and so on. So if you want to spread the word and you think this is of use, please, click subscribe and recommend then to friends or students or people that you might know might find some value from this. Now, today, guys, we're going to focus specifically on geologic geometry, and we're going to focus on earthworks and mining. Okay, typically that's the way the question would be broken up in an exam situation. The first part would be the earthworks of or groundworks for a particular road, or it could be a swimming pool, or it could be a golf course, whatever it might be. And then the mining part would be generally the part B, where we're actually looking at, extracting materials from within a hill or a mountain or whatever it may be, and how we'd actually get down to it and so on. So first things first, what do I have on the page? Because I remember when I was in school and when I saw this for the first time, it was quite intimidating to look at, because in the world of drawing, normally everything's quite linear and quite measured looking, and then suddenly now you're presented with a map. And you might be thinking, well, wait a minute, this looks more like geography as opposed to design and communication graphics. So the first thing you have to do is just kind of, accept that this here is a map, and we are actually going to draw on top of this map. And this map is a plan view, all right? And the scale of the map is 1:1000, okay? So essentially what I have here, this is like an ordnance survey map or so on. It's at a scale of 1:1000. This is a plan view, the whole lot of it, okay? And what we have is we have some information relating to the actual contours that are defining the shape and surface of the ground that's been represented on the map, okay? Now, what's a contour? For example, we have these numbers here, 50. That means that this contour line represents a height of 50 millimeters off, or 50 meters off the ground, 55 meters off the ground, 60, and so on. And you can see then they cluster together in certain places. That might indicate that we might have a slight hill, and so on and so forth. Okay. Ultimately, what we want to do in the first place here with this particular question is we want to look at the earthworks, and we want to look specifically at this aspect here, which is a roadway. Okay. And you can see here the road surface, A, B, C, all the way along here. What we want to do with that road surface is we want to find the earthworks to accommodate this roadway into this particular area. Now, as you can see, the roadworks are done on the southern side of the road, and you'll hear me say southern and northerly and easterly and westerly as we move through the lesson, because these are important factors when you're working with maps. All right, that's how we reference direction and so on in maps with our standard north, south, east, and west. Okay, and you can see up in the corner I have it indicated there. Okay, so we have to do the roadworks here on the northern side of the road. All right, now in doing so, we need to acknowledge the information we have, and this is an example from 2009, the higher level exam paper. So if you want to refer back to this, you'll find that, and you'll also find, if you go through the digital resources that I have available, go into the DCG playlist and you'll find a digital version of this particular lesson here today. Okay, now, so the information, let's have a read. What's given to us? Earthworks information. Complete northern side of road. Ground contours at 5 meter vertical intervals. ABC is the center line of the road. The cut, 1 and 1. Fill, 1 and 1.5. And AB is level at an altitude of 40. And BC has a gradient of 1 and 15 rising. Now, you're probably bombarded or bamboozled by all that information, but let's take it one little piece at a time, okay? So now what I'm going to do is I'm going to relate the information that's been given to what's actually on the map, so we can start to make sense of what's there and how we move forward. So first thing, ground contours at 5 meter vertical intervals. You will see here with the numbers, 50, 55, 60, 60, 55. Each of these numbers were either going up or down 5 meters at a time, Okay, that's because on the map, you know, there needs to be a reference between different heights. And in the case of this map, everything is at 5 meter vertical intervals. Okay, and at a scale of 1 is to 1,000 for you guys at home, that 5 meter vertical interval is going to be 5 millimeters as we draw it out. And you'll see when we get to that. Now, cut 1 and 1. What's a cut? A haircut, a cut in my hand. What is it? Well, a cut is actually a feature of geologic geometry, in particular the earthworks, where we're actually cutting material out of the ground. That's why it's called cut. So if you have a little look down the section on the bottom here, if you've ever been on a motorway, and I know I have some students who live quite a distance from a motorway, they mightn't have been on one, but here's a good view on. If you're going down a motorway and you have the embankments either side, okay, going up, you'll notice that. That means that the road, that material has been cut out to allow us to form the road surface, and that's formation, okay? So the road has been accommodated into the ground by the fact that the material has been removed. So we've cut, okay? And cut is, in this case, in this question, represented as 1 and 1. But what actually is that 1 and 1? That represents the angle of the cut. So if I was to get my protractor out at the side of the motorway, which could be quite dangerous, I wouldn't recommend it. We could go over to the side and we could measure the angle, okay? And that angle might be 45 degrees. And in the case of this question, if we had 1 and 1, that means the angle of that would be 45 degrees, okay, on both sides. That would be the angle of the cut. And generally speaking, we have these things called a cut cone and a fill cone. We'll get more to them later, but the cut cone would represent, the side of the cone would represent the angle that the surface is cut at, okay? So 1 and 1 for the cut, and for the fill, the same idea applies. It's 1 and 1.5 though, all right? And the fill is basically where the ground was lower than the road surface in the first place. So the ground needed to be built up to accommodate the road surface. So in that case, you'll see here, this is the what we're given, 1 and 1.5, and you can see the angle there. We'd go out 1.5 and up 1, and it gives us an angle. And that angle actually would be less than 45 degrees if you were to draw it out, okay? And there's a fill cone and so on. So we won't get too bogged down. I will explain, though, that these little fellas here, okay, these are called tadpoles, okay? And they are typically used, you know, they are used in official drawings for roadworks and so on to indicate the direction of the ground, okay? And the rule there is tadpoles always swim uphill, okay? So you can see here with the cut, all right? You see the tadpoles are in this direction and the fill are in that direction. That indicates at a glance to an engineer or whoever is looking at the plans that the actual tadpoles are indicating the direction of the ground. And as you can see there on the little sketches, that's what we have. Okay, now getting to the drawing part of it. So what we need to do is we need to do a little calculation here first. So we're actually going to do a calculation for the cut contours first. And the cut contours are going to be like a series of lines that are going to intersect the contour lines that we have on the map, and they're going to allow us to find the necessary points on our cut line, which will represent our actual earthworks for that part of the road. So cut contour. So all I do here, guys, I take the vertical interval value, which I'm going to talk in millimeters now, which is 5 millimeters. I'm going to write that in, and I'm multiplying that by the second number in the cut, 1 in 1. So I'm multiplying 5 by 1, and that equals 5. Okay, so each of my contour lines, cut contour lines, they're going to be spaced 5 millimeters apart on the actual drawing here below. The fill contours, we're going to take the vertical interval value here, which is 5, again 5 millimeters, and we're going to multiply it by the second number in the fill, which is 1.5, and that is going to give us 7.5. Okay, and I'll just put in the values there, like so. So we have 5 mil and we have 7.5 mil. The cone calculation, we'll do that in a minute. So what I'm going to do is I'm going to focus on this part of the road here, A to B first. And it said up here that A to B was level at an altitude of 40 meters. So what I'm going to do is I am going to, from the side of the road, okay, we can take it that this line at the side of the road is at a height of 40 meters. And what we're going to do is we're going to step out now, okay? And as I do that, I would generally mark on the very side of the map here, okay? And I'm going to mark out, so if that's 40 at the side of the road, then this one here is going to be 45, 50, 55, and 60. So essentially what these lines are representing, they're representing height lines, okay? And those height lines represent the cut contours that are going to be generated, okay? So at that, and you'll notice when you're doing a cut, the numbers will always rise the further you go away from the road, okay? So what I'm going to do now is very likely now with my, and again, I have everything kind of pre-marked here. I'm going to draw a series of these cut contour lines, okay? So I don't want to waste time needlessly. Now what I'm going to do is I'm going to highlight the points that they cross. So for example, 40, okay, is the side of the road. I'm going to look at this first contour, it's 50. So I'm going to, where it intersects the cut contour line, the blue line here, that's going to be a point, okay? Where 55 meets 50 or 60 meets 60, and that'll be in two positions there. 55, 50, 45, and then 40 hits the edge of the road right there. We stop it right there, okay? So all I do then, okay, is I just join in off the edge. That little hump there at the top of the curve, guys, can be 2-3 mil. I'll give that a little bit of color now, and we'll be able to proceed on to the next part then, okay? That is as simple as that. You see, it's all about deciphering the information that you have. The actual execution part of this question doesn't take that much time at all, okay? So that's cut. And then tadpoles are swimming uphill, okay? Great. Moving on. Next part of the road, B to C. B to C is, the road is rising, okay? So, and it's a gradient of 1 in 15, okay? Now, you're probably thinking, what's this fella talking about? Every 15 meters I travel on the road, the height of the road surface is going to rise 1 meter. So if I travel 30 meters, I rise 2 meters. If I travel 45, I'm rising 3 meters. If I travel all the way out to 150, I rise 10 meters, okay? So that means if I was looking back at my friend who was at point B and I was 150 meters up this road, I would be 10 meters higher than him. I'd be looking down at him, okay? So what way do we actually do the contour lines for this part, and is it going to be a cut or is it going to be a fill? So I just want to write in here cut contours. That's just to reference that. In this area here, if we're at a height of 40, we've got to look at potentially in this area what contour lines we have, that what height they're at, okay? So for example, as I look here, I have 40, then I have 35, 35, 40. That's a little bit away. That doesn't bother me. That's 40, 35, 30, 25, 20, 20, 25, 30, 35, 35, 40. So all of these values that are intersecting with the road in the area that we're going to do the earthworks for, they're all below 40, okay? So that tells me that the ground is too low and it needs to be filled up to support this road as it's rising up, okay? So in this instance here, we are not doing a cut like we had here. We're actually going to be filling this area with material to support the road, okay? And what we have to find now is, number one, how do we determine the lines, the fill contour lines, and then how do we actually find the points themselves on the actual fill line, okay? Just to remind you, this is the cut line here. Okay, now, so for this, we're going to jump back over to this side here. So it says PC gradient 1 in 15 rising, and we'll go down here to the where it says cone calculation, right? So every 15 meters I travel, I rise 1 meter. Okay? Every 15 meters I travel, I rise 1 meter. And I'm always of the mindset with this particular part of the question that you make this as simple as possible for yourself. Because what we're going to do is we're actually going to use a fill cone here. And this fill cone is going to be like a cone that's going to sit under the very edge of the road. That's going to give us an angle to draw these lines off. Okay? These the fill contour lines that we need here. Okay? So how do we get the radius for the fill cone? Because that's the important thing here. And you want to make that as easy as possible. Well, if I think about it, right? If I travel 150 meters down this road, that'll give me a 10 meter rise, okay? And this is going to be a fill cone. And that fill cone, all right, is in an area that needs to be filled. And what's our ratio for our fill? Fill is 1 in 1.5. So what I'm going to do now to calculate the radius of the cone down the road is I'm going to multiply 10 by 1.5. So I'm going to multiply the 10, which is what I call the rise value. Okay. And I'm going to multiply by 1.5. Okay. And if I multiply 10 by 1.5, so cone equals 10 multiplied by 1.5, that equals 15. Now, we don't have to be honors math students to figure all that out, lads. So that's fairly straightforward. 15 millimeters. That's the radius for the cone equals 15 millimeters. Okay? So hopefully that makes sense to you there. Now, it'll make more sense when I actually draw it out for you, okay? So what I'm going to do is I'm going to measure 150 millimeters down the road from point B. 150. And I've picked 150, as I said, because it gives me a nice, straightforward measurement, all right? When I actually am looking for a radius. So what I'm going to do off the side of the cone here is I'm going to mark out a line. So I'm going to call this point B1, okay? So B1, and we just put at 150 meters, okay? And at 150 meters is distance from B. So what I'm going to do there, guys, I'm going to draw a line straight out, okay? Just extend it on out, okay? Don't worry about the length of it for the moment. Make it a construction line. Where that line intersects the side of the road, that's going to be the center point there now for my my radius to be swung, my cone radius, okay? So I'm going to get my compass out. As per the measurement here, 15 millimeters, that's what we calculated. I am going to set that on my compass. 15, 0 out to 15. Make sure you're good and accurate with this because you're a little bit off. It's going to show in each of the lines that follow after. So compass in there, and I'll just swing half the cone here at the side of the road, lads, just to keep things nice and neat. You should be able to see that there now. Okay, so there's my cone. All right, I'll just give that a little shade of color just so we can kind of relate to it. That is my fill cone, and again I'll just put in the necessary information there now in a minute. Okay, fill cone. Or okay, now, so I have that. What way do I use this fill cone? Well, I get my set square, guys, and I line it up tangentially with the cone, with the base. That's the cone base, naturally enough. And I am actually going to draw all the way back now to point B. Okay, so I'm going to line it up with point B, tangential to the edge of the cone, and I'm going to draw it out like that. Okay, now imagine now that this is the side of our road, guys. Okay, I'm after taking, that's the line, it's at 40. Okay, that's the one that's at 40. I'll write that down there. Okay. So perfect. Now what we want to do is we want to base everything else off that. So we've got to calculate here our fill contour calculation, just our standard fill, right? Forget about the cone now. We're done. So what we want to do is multiply 5 by 1.5, we get 7.5. So the fill contour lines, okay, they're going to be 7.5 millimeters apart. So this is what I recommend, and I kind of have this pre-drawn in already, is I recommend that you guys draw a little line at a right angle off the end of your tangent line here, if you want to call it that 40 line. So from point B, draw a line at a right angle off that, okay? Little tip when you're drawing a right angle line, use the inside of your set square, like so, to line up with the line, and line the outside edge up with point B, and you'll get the right angle line. That's the quick way of doing it, okay? Now, on that then, I'm going to mark out my 7.5 millimeter intervals, okay? So I'm going to mark one here, 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 and here. And I'm going to write the heights in beside them, okay? So this one is 40, all right? The next one then is going to be 35. And as you do a fill, you'll notice that the values decrease as you move away from the road because you're moving towards the ground. 30, 25, and 20. Okay? 40, 35, 30, 25, 20. Great. Now what I'm going to do is parallel to this line here, use your sliding set square. Okay? Just throw that on there. Lovely. And now I'm going to draw those lines parallel from those points I just found. There's one there, 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 and there. Okay, and again, these are fill contour lines, okay? So I'll just write that in, fill contours. Okay, now, what I'm going to do is I'm going to mark off my points wherever they are. So 40 is there at the edge of the road, then 35, we've two 35s here, so I'm going to come down to that. There's 35, there's 35. Then we're coming down to 40. 40 intersects 40 here and here. Okay. And then we're going over to 35. You see, you have to be careful here. You got to follow them around. 30, 25, 20, 20, 25, 30, 35, 35, 30, 25, and 20. Now, you can see all them dots I have. I'm going to join them up now as best I can. Don't be worrying too much. Just when you are doing the little hump over between 2 points, if you're at the top of it and you have 2 points at the top, just 2-3 mil hump and bring it back down, okay? And bring it back down to here. Likewise, if you have a little hollow, and on we go. Lovely. Now that is my fill. Okay. Okay. And tadpoles again, they're going to be swimming in this direction. Don't have to put too many of them in. I don't want to delay too much time. We're already 20 odd minutes in. Okay. Give that a little bit of color there. Okay. Now, guys, I hope that has helped you in some way. If you are looking at this as a potential option in your exam, as a question that you're going to do. Now, okay. Next thing, mining geometry. Okay, so the information we're given here, we're told that D, E, and F on the map here, they're outcrop points on the surface. Okay, now we go, like, what's an outcrop point? Well, outcrop points are like, say, for example, if I'm walking on a hill, okay? If you have a look at the little example down here, here's the hill. Here's D, E, and F, all right? These outcrop points would indicate that there's a certain material within the hill. So, for example, if there's gold inside this hill, there might be very small deposits of gold at these locations on the surface, all right? and thus they would be termed outcrop points. Now, when we have a series of outcrop points, we can generate some information that might help us to understand where exactly the material is inside the hill, how thick it is, the angle it's at, the quantity involved. If I was a gold miner, would it be worth digging out this hill for all the money you put into it as opposed to what you get out of it, and so on. Okay, so what we want to determine here is we want to determine, in the first case, the dip and strike of the stratum. Now you're going, what's a stratum? A stratum, if you look at it here, is actually the vein of material that's inside the hill. So you can imagine you have layers of mud and stone and sediment. Next thing you have the layer of gold, and then below it you have more mud and more sediment and rock and so on. So that vein that we're focusing on, that stratum, all right, that's the material that's within the actual hill itself that we want to get at. Okay, the strike is a line, okay, is the direction of a horizontal line on the surface of the stratum and is relative to north always. And if I was a mining company and I wanted to figure out how I was going to get at this, I would always be looking for this strike first, because that's going to help me to put down, say, for example, actual mine shafts that people could get down and mine the material out. So that strike is really important. The second thing that's mentioned there is dip. Dip is the angle that the stratum is at to the horizontal plane. So let's say we're within the hill. What angle is it inside the hill relative to the flat ground? That's your dip angle. So a strike angle is a strike angle along the surface, the top surface. The dip angle is the angle of the actual vein of material itself to the ground. I hope that makes sense. The top surface of your stratum is generally called the head wall, and the bottom surface of the stratum is called the foot wall. Okay, so header, footer. Think of a Word document or whatever. That's what that means. Okay. Now, so the dip and the strike. I'm not going to delay out this. Let's get on with it. The first thing we have to do, and you'll get 3 marks for this all day long, guys, in the exam, is join the lines. Okay. So I'm going to join up like so. Okay, and I'll do that in a kind of a pink color if you can see that. Now, so I've joined them up, lovely. What I want to do is I want to get a level line on the surface of this triangle, right? Remember, that triangle is just like here in the plan view. You have F, all right? If you look at it here, F is at a height of 60. E is at a height of 45. Of course, I have them noted here. And D is at a height of 35. And you were saying, well, this is a plan view. This is a plan view, but these indicate the heights of those points as well. If we were to draw an elevation, we would actually have heights. And we will be doing auxiliary views here where we'll have to take those heights into account. Okay, so they're really important for us. It's really important for you to notice where exactly those points are in terms of a contour and a potential height that they're at. Okay, now what we want to do is we want to find a level line on this surface. Okay, now there are 2 ways. We could go and draw an elevation here. We could take the heights that we have, 35, 60, 45, and we could get a triangle. And just like in the previous lessons I've done with you in terms of the true inclination of a plane, I could take a level line across that triangle in the elevation, drop the point down to plan view, and form the strike line. All right, and that strike line would essentially be the true length of the level line that we would have drawn in the elevation. So if you want to, you can link that back into what we've already done in the previous lessons, okay? So you can see how things match up. Even if we're in this weird looking map question, we can actually link it back to the coordinate geometry examples we were doing earlier, okay? Very important, because geometry is a language, guys. It's like, you know, if I wanted to write an essay or an article for a newspaper, I'd still use the same words, all right? And these are like words, they're methods we use, and so on. Now, what I want to do here is I want to show you the quick way of doing the level line without you having to go and draw an elevation, okay? Because you'll see here there's lines everywhere and so on, and you'll be very tight for space on your actual exam paper unless you put paper behind it. So I'm going to look at which of these points is highest, lowest, and in the middle. If I look at it, D is at 35, that's the low point. F is at 60, that'd be the high point, and E is at 45 meters, and that'd be the middle point. Now, that's nothing to do with the way they're arranged here. That's just how it looks in plan view. I'm taking the heights, which are indicated by the contours, and I'm evaluating that information only in this case. So E is the middle point, right? And that's at 45 meters, okay? What I want to do is on this line here, I want to find a point that's 45 meters off the ground as well. Because if I have 2 points at 45 meters, what would that give me? It would give me the true length of a level line on the surface of this triangle. Okay? That's what I want to find. So if I take D to F, D is 35, F is 60. What I want to do is I want to look at the distance between D and F. So 60 minus 35 equals 25. So there's a 25 meter distance between F and D. Okay? What I'm going to do is I'm then going to look at it and I'm going to see, right, the vertical intervals are at 5 meters. Okay? So I'm going to divide 5 into 25. And that gives me 5. Okay, and what I'm going to do is I'm going to divide this line now into 5 parts. That's why I did that. Okay, 5 parts. That's how you determine the number of parts. So I'm going to get my glue here. I'm going to draw a line at a random angle. We know how to divide a line. I'm sure at this stage I won't go into massive detail on that. Just draw a line out, okay, any length. Mark out 5 equal units. I'll mark out 5 tens, all right. I'll mark them out this way so you can see them a bit more clearly. So there's 1, 2, 3, 4, and 5. I join the last point to point F. And then I use my sliding set square to draw each of those lines in at the correct angle to hit the line, okay. Now, where each of these lines hit the line DF, that's a different height, okay? So this would be at a height of 40. That's at a height of 45. That's at a height of 50. That's at a height of 55. And that's at a height of 60, okay? So now I have a point on this line, which is what I wanted, at a height of 45 meters. So what I'm going to do now is I'm going to join that 45 meter point there to the 45 meter point at point E. Okay, that is my strike line, guys. Okay, that's the strike. And we'd nearly always put the arrow on the strike, you know, if you want. You can look at it like that. Okay, that strike is this point, this line here on the surface, the top surface of the stratum. Okay, and what we're going to do and it's a true length line. Okay, it's a true length. When we have a true length line and we're going to set up an auxiliary view, all right, we can actually project the x1, y1 at a right angle to that strike line. So I'm going to set up an x1, y1 now, and I've already pre-drawn that line. So this line is going to be at a right angle. You can't see the pre-drawn lines because I've them done very, very lightly, okay? x1, y1. Now, I'm going to project the points D, E, and F out. So I get again, I have the lines drawn at I'll use the green for this, lads, or here we go, I'll go back to the blue. So I have the lines already pre-drawn at a right angle, so from point D, I'm drawn out at a right angle through the x1, y1 line and on out. Okay, I'll show you how I mark the distances in a moment. And likewise from F. Now, I have those lines drawn out. What distance do I mark out? You're thinking, sure, this is a plan view. I don't have any information, or do I? Yes, I do. I know the heights of each of these points if they were to be in elevation. All right, 35 for D, so I mark out 35. There's D. For E, it's 45. So I mark out 45. E. And then finally F is 60, so I mark out 60. There's F. Okay? I get a line here, guys. All right? This is the head wall. Okay? The head wall being that top surface of the stratum. Okay? So I'm just going to write head wall in there. Okay? Now, you might think, well, sure, why would I not just write top surface of stratum? Well, it's the same thing. It's just one word as opposed to 2 or 3. Okay? The head wall right there. Now, what this gives us as well, if I take a line that's parallel to the X and Y one at point D, or anywhere in relation to that line, I can actually get what's called the dip angle. Okay? So I'm going to put in a symbol here, theta. I'll get my compass. I'll be official about this. And I'm going to put little indication arrows there. That angle there that's created, that is my dip angle. And the dip angle is the angle of the stratum to the ground, to the horizontal plane. Okay? So that's the kind of the first part of that mining looked after, right? So we've connected the points. We found a point on one line of the triangle that was level with another point on the triangle. That gave us a strike line. We projected at a right angle, took the measurements from the points here, all right, because they indicated the heights where they were on the contour lines, 35, 45, 60, stepped them out, and then we measured the angle as a result. And we have one line at the top of the stratum. However, we don't have the bottom line of the stratum. So it says here in the second part of the question, it says skew borehole at D drilled in a northerly direction in plan. Okay, northerly, so it'll be going straight up here somewhere, and has an actual inclination of 45 degrees to the horizontal plane. All right, so if I were to look at this line in the horizontal plane or in the elevation, I would see it as a 45-degree line. In the plan view, it looks straight up, but in an actual elevation, it would be at 45 degrees. And I'm going to show you how we're going to draw that now in a second. It reveals the bottom surface stratum at a distance of 20 meters from D. So 20 meters from point D, okay? So this is what we're going to do. Firstly, I'm going to indicate the northerly direction in the plan view from point D, okay? And a skew borehole, by the way, is a borehole drilled at an angle, all right? Normally speaking, you'll have, let's say at F and E, they're just vertical boreholes. At point D, it's a borehole that's been drilled in at a different angle, okay? An angle that's not 90 degrees, okay? For mine shafts and so on, you could probably take F and E if you were to go straight down a vertical borehole, but you probably couldn't put a mine shaft in on a skew borehole because the borehole's at an angle. Okay? Depends. Now, so point D here, what I'm going to do is I'm going to use if we go for a bit of green. Okay? Going to draw a line, northerly direction here. Just draw it on out like that. Okay, and I'm going to put a little arrow on it there like that. I don't know the full length of this borehole line at the moment. Okay, don't know that. So I just draw it out there. It's fine. Okay, so that's the northerly direction. Okay. All right, that's the northerly direction bit in plan. You might go, well, yeah, there you go. All right, northerly. Great. What I'm going to do is I'm going to set up an X1, Y1 now. All right, because I was given information here, the 45 degrees to the horizontal plane. When I see that, I'm thinking elevation straight away. Now, I could draw an elevation up here, but we're limited with space. Or I could draw an auxiliary elevation just to the side here, parallel to the borehole that I just, the skew borehole. All right, I'll just put in skew there as well. Okay, now, so I'm going to set up an X1, Y1 here now. Doesn't matter how far you come out, lads, just whatever. Okay, let's say I come out about 20 mil there. I'm going to call that X2, Y2 because I already have an X1, Y1. Okay, so X2, Y2. I'm going to project out, okay, point D at a right angle to that. Okay, remember that's parallel to the borehole. Okay, and if that borehole was at an angle, I do the X2, Y2 at the same angle as the borehole. Okay, you get the picture. This is an auxiliary elevation. Now, just like the way this is an auxiliary elevation, on this side we now have two auxiliary elevations. We're going to show how they match up in a minute. Okay, so I'm going to project out now from D to the X1, Y1. Now, I want to locate D. I know D is at a height of 35. If this is an auxiliary elevation, that means I get 35 on my compass, and I step it out. Like so. There we go. So there's point D now in my auxiliary elevation. Now with that, what I'm going to do is I'm going to drill the borehole here, as it said, at 45 degrees. So I'm going to give that borehole, it'll be in green, just like the way it is in the plan view. And I'm just going to drill it on there. Don't worry about the length of it there at the moment. Okay? Drill it on. All right? Skew borehole. Okay, I'll just put D in at 35 meters, and we'll say that's the 45-degree angle there. Yeah, that keeps everything nice and in line. Okay, so what it said there in the question, it says it reveals the bottom surface of the stratum at a distance of 20 meters from D. Okay, and this is what we're looking for. We're looking for the bottom surface of the stratum over here, but we're using the information here to find it. So what I'm going to do is I'm going to measure 20 millimeters from point D on that line I just drew at 45 degrees. Mark a point, okay? Be able to see that point right there. That's the point now. I'm going to call that point P, okay? P, right there. We're taking that point P back to hit the borehole in the plan view. So I'll project that back like so. And I use indication arrows just to show that that's a moving line, a moving point. Here we go, P all the way back, okay? I'll just write in the 20 millimeters there as well. 20, okay? Now, once it hits here, we're going to bring it back into this view at the same angle, okay? As the rest of the lines. So that'll be the blue line here, so but I don't know where exactly just to stop it just yet. So I draw that line tentatively. Okay. Now, so it's at the same angle as the rest of the projection lines going out. What I want to do is I want to take the distance between the X2, Y2 and point P, right? Because this is an auxiliary elevation, yeah? And this is an auxiliary elevation. So if this is the bottom point now here that we located, well, surely the bottom point on the surface here is going to be at the same distance, isn't it? So I get my compass between the X2, Y2 and point P. I'm taking that distance, follow it over to the X1, Y1 line on the line that you have projected for point P and swing it out. Now I have my point P located in the auxiliary view. And all I have to do then is use my sliding set squares to draw a line parallel to the head wall line, and that's my foot wall. And the beauty of this is what that indicates to us, if we draw a line between the two lines at a right angle, I'll do this with a little bit of red. What we have now is T, which is the thickness, the actual thickness of the stratum, okay? So if I was to draw a little arrow out, thickness of stratum. So if I was this gold prospector, this is what I would be looking for, guys. I would be looking for the thickness of the deposit of that vein of gold, that stratum of gold that's within the hill. All right, and I would have to go through these procedures. For example, find a strike, find a dip, determine the top and the bottom points, and be able to then produce these two lines here to give me the thickness of between the head wall and the foot wall. And then from that, I could go, right, this thickness, if I measure it, it's 19 millimeters. So that's 19 meters of gold thickness of gold and it runs for whatever distance, that's worth investing in. Okay, lads, so that is the lesson complete. I hope you've enjoyed it. Again, you want to take a screen grab of that when you have in your own time, when you want to look back over. Just tilt that a little bit there. You'll be able to see all the information, the notes that I wrote down. I know there was a lot in it, but if you break it down and you're able to look at your information objectively and you understand, particularly in the mining geometry, that this is an auxiliary elevation. This is an auxiliary elevation, okay, and so on, and that we're able to use our information between the views to get what we want, then it shouldn't be any bother to you, lads. Okay, look, thanks very much for your time. All right, again, as I say about the situation at the moment, be careful, keep your distance from other people, but do get out, get a bit of fresh air, keep the mind fresh, keep active. All right, and wishing you all a very good day. I'll be on again tomorrow at 9 o'clock in the morning if you're up early. Otherwise than that, good afternoon, good evening, and good night.